So we just recently talked about our GCF method and hopefully the practice went well, but now we're going to be talking on what we call the product sum method. And this one's actually my favorite. It's kind of like a little bit of a puzzle to me. So traditionally we call this either product sum or the diamond method. And that's traditionally what works best for students. Now, you can do it in multiple different ways, but where I usually like to see the diamond method is by looking at my last value. We're trying to find what value, so remember we have our standard form, which is y is equal to ax squared plus bx plus c. And what we can discover is that when we have our c value and our b value, so our c value here is 12 and our b value is 7, so this is our B, and this is our C. We are looking for, hey, what two numbers multiply to C, but add those same two numbers add to B? So when we do that, we use this little diamond method where we say, okay, what two numbers multiply to 12, but add to 7? So let's break that down. If I'm looking at my factors of 12, I have my factors of 12 times 1, 6 times 2, and 3 times 4. So those are my factors that I could possibly put here or here. But let's look at which ones add to 7. So 12 plus 1 gives me 13. That's not it. 6 plus 2 gives me 8. That's not it. We're closer though. So that means 3 plus 4 has to be the breadwinner, which is what we're looking for. Oops. So that's what we're looking for. So our 3 is going to be one of our factors and 4 is one of our factors. And it makes sense. 3 times 4 gives us our 12, but 3 plus 4 gives us 7. So now that we have this, our factored form is x plus m times x plus n. So I'll identify my 3 as my m and my n being my 4. So I'll have x plus 3 and x plus 4. Let's do another practice one. So I'm going to skip this one because this one's pretty similar, but I want to talk about when our factors of C, when we have either we're adding, but we have a negative number at the end. So here, when we're looking at our factors of C, we're trying to find what two numbers multiply to negative 90, but add to 13. And this is a positive 13. How can I get a negative number but add to 13? Well, we have to break it down. So if we're looking at these problems, we're trying to see, okay, what are our factors of 90? And this is where we have our factor chart, which is super important. Our factor chart is really important to help us understand. So let me look through our factor chart. And you can look this up either online or wherever. And our factor chart of 90 means that we're going to have 1 times 90, 2 times 45, 3 times 30, 5 times 18, 6 times 15, and 9 times 10. So there's a ton that we have to try. But if we're multiplying to a negative number, that means that one of our values is going to have to be negative, and one of them also has to be positive. So when we're looking at our m and n, so we're setting y is equal to, we're going to have x plus a number and x minus a number. So let me start practicing. If I'm adding to a positive, if I'm trying to add to a positive number, that means all my bigger numbers need to be positive and all my smaller numbers need to be negative. So let's try that out. So 90 plus a negative 1, that gives me a positive 89. Not quite. How about 45 plus a negative 2? Well, here I see that I get closer and I get a 43. Then I have 30. Oops, wrote that a little weird. 30 plus a negative 3. That gives me a negative 27. We're getting closer and closer. We're not quite there yet. Now let's look at 80 plus a negative 5. Or sorry, 18 plus a negative 5, which that gives us, oh, look at that. Now we have our 13. So I have my positive 18 and my negative 5. So therefore, when I look at my numbers, I'm going to be having x plus 18 and x minus 5. Let's do one more practice before we start looking at how do we start from our standard form and factor it using our product sum method. So here we have our standard form of x squared minus 6x minus 16. And I have a negative number in the front. So here my b is going to be negative. So I'm finding what two numbers multiply to a negative 16, but add to a negative 6. So let me list my factors of negative 16. And if you need your factor chart, I highly recommend to use it. So 16 times 1, 2 times 8, and 4 times 4. In order to do this, I need to now find a negative number. So instead of having my bigger number be negative, now I need my smaller numbers to be negative. So that means that my bigger numbers need to be negative, because if I'm adding a more negative number, it's going to stay negative. So for example, I have 1 plus a negative 16. That gives me a negative 15. 2 plus a negative 8. Well, that gives me a negative 6, which is what I'm looking for. And for just to see and make sure, a 4 plus a negative 4 gives us a 0. So when I look at this, I'm going to use where I have a positive value and a negative value, where my 2 is going to be positive and my 8 is going to be negative. So therefore, I have y is equal to x plus 2 times x minus 8. And remember, guys, just like how you could do in your factoring, you could also, when we did the GCF and we could check our work, if you multiply these two factors, if you multiply them, you can check your work. So if you multiply them and get back to your standard form, so you can multiply them and get back to our standard form, that means you know that you made the right steps. So here's one where you have a practice where first we're going to identify that we're using our product sum. So you're finding what two numbers multiply to 24, but add to a negative 10. This is where I want you guys to practice now using one of our two methods that we just did. So we know that we're not using our GCF here because we have no fact that we can pull out. And we haven't talked about difference of squares, so it's not going to be difference of squares. So therefore, we're going to have to use our product sum, which is what we are using. So I want you guys to find your y is equal to x plus a value and x minus a value here. Hopefully you guys were successful. I do want to go over one last thing. So when we are looking to write it in factored form and then find what we call our x-intercepts, remember, let's go back to our key ideas. So if we go all the way back to our key ideas, our x-intercepts are where our y is 0. And we need to find our factored form first. So if that's the case, let me go all the way back down to our problem, and I have to be able to figure out that here I'm using my product sum, so I'm looking at what two numbers multiply to negative 12, but add to 11. And let me list my factors of 12. So I have 12 times 1, 6 times 2, and 4 times 3. And if I'm trying to add to a positive number, that means I have to have my bigger number be positive and my other number to be negative here. So I have 12 plus a negative 1, or I could have 6 plus a negative 2, or I could have a 4 plus a negative 3. And right away I can see 12 plus a negative 1 gives me a positive 11. So I know those two are my right solution. So I'll have y is equal to x plus 12, x minus 1. But here we're not done. We found our first part. Now we need our second part where we set our y equal to 0. So here if I have 0 is equal to x plus 12, x minus 1. Now I need to set each portion equal to 0, so I can have x plus 12 is equal to 0, and x minus 1 is equal to 0. If that's the case, I'm going to subtract 12 onto both sides, so x is equal to negative 12, and x plus 1, if I add 1 onto both sides, now I have x is equal to a positive 1. So now that we've done a practice solution where we have two of our solutions, now that we have our two x values, we are all done. We have found our x-intercepts, and now we have solved. Now it's your guys' time to practice one more time, and then we're going to be moving into difference of squares.